Welcome. My name is Deepak Kumar Thakur. I am a third year Electronics and Telecommunication Engineering student at Dr. D.Y. Patil School of Engineering, Lohegaon, Pune, Maharashtra, India. Currently, I am an intern in Emertxe doing an internship in embedded system in which we are designing an car black box. This presentation is for the demonstration purpose of the finished product that we have made. Before I go through this presentation, let me mention what I have planned how to go through this presentation. First, we will see the brief overview on the topic of contents that I have prepared: introduction, requirements, designing aspects, tools used, and learning outcome. And at the end, we will see simulation and full aspect of this project. Now let's begin with the introduction. Car black box. Before knowing car black box, let us see what is a black box in general. The black box is an extremely durable electronic device capable of recording valuable information in the moments. So, this is a durable electronic device which can record information in a moment, like for say half a second or a second. A car black box is a device which is installed in a car physically or that can be downloaded through a device which stores the events that has occurred with the car, like collision, gear change, or the GPS location of the car. A small machine that records the detail of each travel and is useful for finding out the cause of the crash of accident. Now let's see the requirements of this project, or what we have learned in this internship during the 4 weeks duration. In first week, we have seen the basic knowledge about embedded C language. In the first week, we are introduced to C language and data types. Second day, conditional constructors and operators. Third day, operators and arrays. Fourth day, pointers and functions. Fifth day, recursion and strings. And at the last day of first week, we have seen storage classes and pre-processing directories. On the second week onwards, we have gone forward with the microcontroller and the concepts of embedded system. In the first week, we have seen the first three heading mentioned here: Introduction to Embedded System, Introduction to Microcontrollers, Embedded Programming. On the third week, we have started with the peripherals and the required techniques to use them, like interrupts and communication protocol. And the fourth week was the integration part, in which the teacher shows us how to assemble the peripherals and make a project working. So we have used PIC Genius board with PIC 16F877A microcontroller. We have chosen this board because it has all the necessary peripherals pre-installed and comes with a capable processor for our use case. Now let's see about microcontroller that we have used. PIC 16F877A Here are some features mentioned about this microcontroller with the pin diagram of the microcontroller. So, first, this is a 8-bit microcontroller. It has 40 pins and 5 ports. Port A, Port B, Port C, Port D, Port E. Port E having 3 pins and rest of the ports having 8 pins each. CPU speed is 505 million instructions per second. RAM size is 36 8 bytes. Double EEPROM size which we have used is 256 bytes. Now let's go forward. Peripherals and techniques used. We have used many peripherals in our project like digital keypad, timer slash counter, interrupt or ISR, CLCD or character liquid crystal display, potentiometer or a ADC, analog to digital converter, RTC, real time clock, I2C protocol, inter-integrated circuit, double EEPROM, electrically erasable programmable read-only memory. Now let's see each one by one. Digital keypad. In our selected board, tactile switches are in pull-up resistor interface. So this is pull-up resistor circuit interface, which means when the key is open, the pin at the microcontroller has a value of 1. When key is closed or the switch is on, microcontroller pin value goes to 0. These are the internal diagram of the tactile switches. Now let's see timer. So PIC-16F877A is having 3 timers, namely timer 0, timer 1 and timer 2. Timer 0 and timer 2 is of 8 bits and timer 1 is 16-bit timer. We have used timer 2 and I will mention why we have used timer 2 and not timer 0 and timer 1. Now let's see what is interrupt. So interrupt is a signal given to the microcontroller's main processor that something needs its attention right away. So how timer can generate an interrupt is by overflowing from their width of the register. And since there is another method with a timer 2, which is PR2 resistor's value matches with the timer 2 resistor's value. In that case, it generates an interrupt, and which makes our calculation easier for counting the time or measuring the seconds passed. Now let's see what is interrupt. So interrupt is a block of code which is executed whenever ISR is a block of code which is executed whenever interrupt occurs, which will attend to interrupt and clear the respective interrupt flag. Then program pointer comes back to the line where it was just before going to ISR block. Character liquid crystal display. So in our project, we have worked with 16x2 CLCD, namely HD 44780U from Hitachi. Hitachi is the manufacturer name and this is the model number. 16 cross 2 means that it can display 16 characters per line and having two such lines. It can work in two data modes, either 4-bit or 8-bit mode. We have used 8-bit mode in our project. Potentiometer or analog to digital converter. It converts analog signal to digital signal. In our board, we are having two similar potentiometer of 10-bit resolution, which means that it can give output from 0 to 1023. RTC or the real-time clock provides precise time and date. We have used DS1307 in this project. RTC is an electronic device in the form of an integrated chip available in various packaging options. I2C. I2C is a protocol. I2C is a system for serial data exchange between the two microcontrollers and or specialized integrated circuit of a new generation. In our case, we are using a such specialized integrated circuit RTC and our microcontroller is PIC16F877A. We are having synchronous and half duplex I2C, which means there is only one clock line and one data line present. Electrically erasable programmable read-only memory, EEPROM, is user modifiable read-only memory that allows users to erase and reprogram stored data repeatedly in an application. In this read-only memory, the data can be erased by electrical signals, so it is reusable again and again. In this project, we have used internal EEPROM, which is present inside our microcontroller. The size of the internal EEPROM is 256 bytes. The address range is hexadecimal value 00 to FF. Now let's see the schematic diagram of PicGenius PIC16F877A board. First we will see the CLCD, which is here. So CLCD data pins are connected to D0 to D7, which is entire D port. Port D is working as data pins. E2 and E1, which is in port E, is enable and register select respectively. So these port D and port E2 pins are used by the CLCD. Now let's see the digital keypad. Digital keypad RB0 to RB5 in port B. RB0 to RB5 is connected to the digital keypad or the tactile switches. Here is the potentiometer. We are using only one P1 and which is connected to A0, A and A0. means this one. AR0, it's A and this one. And lastly there is RTC, which having two pins. This is data pin HDA, and this is clock line SCK, and which is multiplexed with here C3 and C4. C4 being the data line HDA, and C3 being the clock line. Now let's see. Now let us see the designing aspect, or the documentation or the requirements presented to us, what the client needs from this product. So the client wants us to design a car black box which can store up to 10 most recent gear changes or collision done on the car. Mainly, he wants us to store the time, gear change or collision and speed information. Here it's mentioned only 10. Now see the second point. When the number of events exceed the limit of 10, in that case override the oldest event with the new one. So if our events list goes beyond 10, the most oldest one will get replaced with the new upcoming one. That's fine. Now let's see the third point. Also, it should have a dashboard which shows the current information about car, time, gear or collision and speed. So the information that we have to store, we also have to display on the real time on the dashboard. And a menu screen to select different features. Now let's see what are these different features. From 3 options, protected with 4-digit password. So the 3 options which is here, which is present in the menu screen, is protected with a 4-digit password. View log, clear log, change password. Okay, and the next requirement is, if user enters wrong password 3 times, we have to ban user for some time, after which he will get 3 more attempts. So if user enters 3, so user will get 3 attempts, and if he fails all 3 attempts, he will get banned. That's okay. And now the 6th point, explaining what they want us to do in the view log. So view log allows user to see records stored in the black box with serial number and allow them to navigate through it with a key press. So we have to dedicate a key for this purpose to navigate from the stored events. Clear log will delete all the old logs present in the memory. So clear log will do what it says. It will clear the log. Okay. Change password will allow user to change the current password with the new one. So he is talking about the 4-digit password, which is used for the protection of the menu screen from the dashboard. So we can change it by using change password. And there is also special requirement and special request. Let's see what they are. Special requirement: no matter what the user is doing, the gear change or collision recording must not stop. So he wants us to record the events even when the user is not on the dashboard or doing something else. Special request: if user not presses any key while on enter password screen for 5 seconds, toss him back to dashboard. So we have to bring him back to dashboard if he is inactive in the enter password screen. Okay. Now let's see how we have managed to do this. Before, we have to see the user guide to how to use this black box that we have designed. So our black box is having 6 keys that we have designed for the purpose, and a potentiometer is used for the speed change. Now let's see the upper 3 buttons, what they does. RB0 is for collision. If we press this button, the black box will consider it as a collision. RB1 for downing the gear or to change the gear to the lower state, or RB2 for up the gear or to increase the gear. And now see what the lower 3 buttons will do. RB3 to navigate up, and it represents digit 1 in the password screen. RB4 it to navigate down, and it represents 0 in the password digit. And RB5 is for select option. And this is our board that we have used, PicGenius PIC16F877A. This is the character LCD, and this is the RTC. This is our microcontroller. This is potentiometer. These are the digital keypad. And now let's see. Now what tools we have used. So we have used 3 tools, 2 for the programming and compilation purpose and 1 for simulation. Now let's see. For programming, we have used MPLAB X IDE, which is a free integrated development environment, which is used for the programming of PIC microcontrollers provided by the same manufacturer who makes the microcontroller. So we have used this, and for the generation of hex file, we have used XC8 compiler, which is a cross compiler. XC8 compiler is from Microchip for 8-bit PICs. So our selected microcontroller is of 8 bits, therefore we have to use XC8 compiler. For simulation purpose, we have used Pic-sim Lab. Pic-sim Lab is a real-time emulator of development boards with integrated MPLAB X. Now let's go ahead with the simulation. I have already opened up the softwares in the background, so it will not take the startup time. Now let's see, this is our project, car black box, and these are the source file. Each peripheral has its own driver code written in the separate .c file, so we can reuse it. So ADC is containing the potentiometers code. Let's see, this is the potentiometers code. This is the initialization. All the initialization is beginning with init, and in car black box, I have written all the functions that we need for simulating this car black box, and rest respectively what their name suggest, and main. So main will execute or call the functions which are present in the car black box according to the command. So first we will see the main.h. Main.h includes all the peripherals header file and define some macros. The respective macros are dashboard, login screen, menu screen, view log, clear log, change password. So we have total 6 macros for representing 6 different aspects of our project. Uh, Now let's simulate this on Pic-sim Lab. So this is our Pic-sim Lab. First, when you open it, it will look like something like this. So to bring it according to our needs, we have to first go to Pic Genius, then click on microcontrollers and select the respective microcontroller. In this case, we will using PIC16F877A, then click it, and then we need to load the hex file. For the generation of hex file, we have to press this build button after writing all the codes. Now let's see. Build is successful. So build is successful. Loading code from. So this is the location of the hex file generated. So we will copy this and go to the Pic-sim Lab, click on files, load hex, click here, Control V, enter, and here is the hex file, car blackbox.x .production.x, open, and here is our car black box. So it is showing us the correct time. So it's 16:29 is the real time. This time is given by the RTC, which is communicating via I2C communication protocol. Now let's refresh what the user guide has mentioned. So this button is for collision, this for downing the gear, this for increasing the gear, this for navigation of up or to enter the password, or it representing digit 1, this for navigation of down and representing value of 0 in the enter password screen, this for selection, and this for changing the speed. Now let's check the peripherals is working. Now this is changing the speed. Now let's emulate a real life scenario. Imagine my car is in the garage. First I have to take this car reverse and then increase the gear. So first I will give some speed and reverse, and after reversing again speed goes to 0 and then neutral, and then I will increase the speed, increase the gear, increase some more speed, increase the gear again, increase some more speed, increase the gear, increase some speed, increase gear again. And now unfortunately I have to check the collision is working. Now let's do a collision occur. Now let's check the event is stored at their respective speed and respective time with order. So let's go to enter password screen. I am not pressing anything for 5 seconds. Now let's see, it throws us back to the dashboard. Now let's enter the password. So password is 4 times 1. So I have to press 4 times RB3 in order to come to this menu screen. So menu screen containing 3 options: view log, clear log, and change password. So to enter the view log, I have to make this cursor in front of this and press RB5. So after getting to after getting to view log, I can see at index 0 at time 16:29 on event is occurred with 0 speed. Now let's navigate down. Index 1, 16:31 after 2 minutes, gear reversed, speed is 11. Again down, index 2, 16:31 neutral, speed is 0. Then gear up with 17 speed, gear up again with 35 speed, gear up again with 56 speed, and fourth gear with 69 speed, and then a collision. And if I press this button again, I will come back to zeros, because since we are no longer having any event after 7, so it is bringing me back to 0 after 7. So what happened if I change gear now after being in the view log screen? Now let's check. Gear up. After collision, I have made a gear up, and now there is a 8th event which was not previously present, and gear 1. After collision, car goes back to neutral. So now we are at gear 1. Now up a gear again, and 9th event is also here. Now if you can see, the 0th event is on, and if I press this, we are at the 9th event currently, and the next event would be exceeding the number 10. So we should rewrite this 0th index with the new one. So now let's check it's rewriting this. Now if we press collision, now let's see, 0 index, collision. Now it's not on, it's collision. And if we press button again, like gear up, so next event will also be getting rewritten. So that's how it's working. Now let's go back to dashboard via clicking RB5 again. RB5. Now we are at dashboard. Now let's check clear log. So first we have to enter password. Password is 4 times 1, and clear log. Bring this cursor in front of clear log and then press RB5. Log successfully cleared, and now we are going back to dashboard. So after getting to dashboard, let me quickly check what is the history of log, and we are going to log. No logs present, so log is not present. Now if I click these button, log will get created and 0 index will get here. Now there's this gear up, G2, 0 index, and let's go back to dashboard. Now let's change the password. So 4 times 1 first to enter the menu screen, then go to change password, RB5. Now enter the new password. So new password would be 4 times 0. So RB4, clicking 4 times. Now enter new password again. So this 4 times 0. Password change successful. Now we are back to the dashboard. Now let's check what happens if we enter the old password. So it's showing attempt left 1. It's wrong password since we have changed the password with the new one. So again we have entered the wrong password. It's showing attempts left 1. Now let's again enter wrong password and see it's banning us for or not. Yes, it's banning us for 60 seconds. Now we have banned and we can't enter password until this timer goes up. So we will wait till the time comes, and let me tell you about this DIP switches. These DIP switches are here since this board is jam packed with the peripherals. Every pin of the microcontroller is doing some kind of multitasking. So this DIPS switches is in charge of what are those functions that pin is performing. Like if I toggle this switch, this display gets off. Since the here is written LCD. If we are using LCD, we have to on this. So that's how it's work. So now let's see timer. Okay, 3 seconds is left. Okay, now we have chance to enter password again. I have entered 4 times 0 and we are at the menu screen. And let's see what happens if we change password again with 1100 and again password I will enter wrong one. So password change failed. So password not get changed. We can check it 1100. It's a wrong password. Since password never get changed, so it's 4 times 0. 4 times 0. And you can see it's this project is nicely working. And that's all for this project. Now, thank you for listening. Uh, Thank you, Emertxe, for giving me this wonderful opportunity for doing this wonderful internship with a very good topic in hand. Thank you.